I'm going to try to finish up this section on 8D, try to do all of page 142. There's a little flow chart here on how you know whether you have more factoring to do or not. We're going to practice it. You can look at the flow chart. I'm not going to read it to you. But I do want to point out that we are going to write our expressions in standard form if they're not already written. That's going to be our first task. So they don't put that on this flow chart, but it is essential to what it is we're going to do. And then also, I want you to memorize. Maybe we'll have a little quiz. I want you to memorize the perfect squares up to 225. So that's 1, 4, 9, 16, 25, 36, 49, 64, that's a 9, 81, 100, let me move this guy, 121, 144, 169, 196, those are easy because the integers just flip, and then 225. So this is up to 15 squared. That's 1 squared, 2 squared, 3, 4, 5, 6, on and on and on, up to 15 squared. You just need to know these. You're going to need to know them for the rest, really the rest of math and science classes and and in college. So it's a good thing to just memorize them now, so I'm asking you to do that. So basically, we are going to, once written in standard form, we are going to look for a GCF, other than 1, because 1 is a GCF for everybody. And then we're going to look for difference of squares, and we're going to, after we factor out the GCF, and then we're going to see if we can go a little bit further. And there's this advanced techniques. Not sure if they're going to introduce you to more of those in the next section or not. But for 8D, this is what we're going to do. So let's work our way through these. So this is not written in standard form. So the very first thing I'm going to do is rewrite this guy. It really looks different when it's written in standard form. So it's easier to see your squares. You're easier because your exponents go from smallest to biggest. So is there a GCF? I don't really care about the difference of 2 squares yet. I want to take out the GCF. There is a GCF. It's a minus 3x out of both of those terms. Once I do that, I end up with that. There's no difference of 2 squares. I'm done. I can stop. This guy, he is written in standard form. That looks fine. Do these terms have a GCF? Yes, they do. X to the first power. So now that becomes 9x squared minus 16. This is the difference of 2 squares. So now that becomes x to the 3x plus 4 times 3x minus 4. And I'm done. I don't have a difference of 2 squares. I can't do anything else. All right, let's look at C. Standard form looks okay. What can I factor out? I see a 2. So I'm left with x squared minus 4. This guy can be factored further to x plus 2, x minus 2. And once again, at this point, there's nothing else that I can see that I can do. I'm looking at this guy. He's in standard form. I don't see a GCF to pull out. There's nothing that these two terms have in common. But I do notice now in my flow chart, yes, this is the difference of 2 squares. So I can go directly to 5m squared plus n and 5m squared minus n. I look further to see if there's anything else that can be factored. I see a difference, but these guys are not perfect squares. So I'm done with that one. All right, let's look at him. He's not in standard form. Minus 3a cubed plus 27a. I see a minus 3a as a GCF that can come out of both of those terms. That leaves me with a squared minus 9. Now you might notice that this is the difference of 2 squares. That sets it up for us to write a plus 3 and a minus 3. And we're done. This guy's in standard form. He does have a GCF. I see 3x that can come out of both of those terms. That leaves me with 4x minus 1. I see a difference, and 4 is a square and 1 is a square, but the x is not. So we can't do anything further with this guy. We have to leave him alone. Okay, here come two larger puppies. Woo. Let's see what we got. Okay, first of all, am I looking for standard form? 5, 4, 3, 2. That looks pretty good. I need a GCF. In all of these terms, what do I see that they have in common? Well, they have a 3c squared is the best I can see. And what do I have left when I do that? I have a c cubed minus 2c squared minus 4c plus 8. Okay, so I'm going to leave this 3c squared alone for a minute, but what do I notice now? I notice 4 terms, and we were able to factor 4-term polynomials by grouping. So that's what we're going to do here also. In these first 2 terms, what can I take out? A c squared. So that leaves me with c minus 2. What can I take out of here? A 4. And that leaves me with c minus 2 also. Remember, this sign and this sign have got to multiply back to that sign. So now our next step inside this grouping symbol here is to factor out these guys that they have in common. So I have the c minus 2, and what do I have left? C squared minus 4. Do you see your fate? You are not done yet. There is another perfect square. So that becomes c minus 2, c plus 2. You think you're done? Not yet. Because I want to write this guy in exponential form. So now my answer is 3c squared times c minus 2 squared times c plus 2. That's that one. Wonder if this one will be as crazy. Doesn't look like it, but maybe. All right, so I have standard form. Yes, 3, 2, 1, 0. Powers of x. I don't even see a common factor or GCF, so that's good. Oh, wait, x squared. Certainly. No. That's the next step. Sorry. I got ahead of myself. So I'm going to try to factor by grouping. So what do I see here? This is where I see the x squared coming out, leaving 2x plus 5. What do I see in common here? A 9. Again, this negative sign comes down. What's left on the inside is 2x plus 5, because I have to get back to this negative sign here. Negative 9 times positive 5. And now I'm going to factor out the x squared minus 9. 2x plus 5 is the common factor. He comes out. What's left is x squared minus 9. And you might see that this is the difference of 2 squares. So this becomes our final answer for that guy. All right, thanks for watching. We'll carry on.